Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In previous video, I explained about bulk modulus of elasticity. So in previous video, I explained about elasticity, right? So elastic modulus is nothing but the ratio of stress to the strain, right? So while increasing stress, strain also will increase, right? So we have based on stress and strain applied. So we have three different types of elastic modulus, right? So one is Young's modulus, another one is rigidity modulus, another one is bulk modulus. Okay, we have three different types of elastic modulus, right? Okay. So in previous video I explained about bulk modulus. So Young's modulus is nothing but the application of the ratio between the longitudinal stress to the longitudinal strain, right? So bulk modulus is nothing but the ratio between the volume stress to volume strain. So normal stress to the normal stress. The application of stress is in the normal to the strain, right? So rigidity modulus is nothing but shearing stress to the shearing strain. So what is the meaning of here shearing? So shearing is nothing but the twisting or turning. The change in angle is called as shearing. So the change in angle is called as shearing. The shearing stress is nothing but the stress will be applied in the angle, right? So rigidity modulus is the ratio between the shearing stress to the shearing strain. So here the application of stress is also in angle. The strain will produced in that material also in angle, right? This is the ratio of shearing stress to the shearing strain. So shearing stress is applied tangential to the surface. As a result, one surface is displaced with respect to another fixed surface, right? So look at this diagram. So here the stress will be applied in the tangential to the surface, right? So here the theta stress will be applied to the body. The material moved, the material surface moved to one surface to another surface with respect to the another fixed surface, right? So here theta angle will be theta angle twist given to that body. So it displaced into x to del x. Okay, so it displaced from x to del x. Okay, here the displacement del x will be produced. This will be the strain of the material. Okay, so rigidity modulus can be termed as a symbol eta. So eta is equivalent to tangential stress to the shearing strain. So here the tangential stress is nothing but the twisting or turning. So the stress applied to the tangential to the surface, right? So tangential stress to shearing strain. So here tangential stress is equivalent to force by area. Here the force application of force with respect to the area of cross section, that is called as stress. Okay, here the tangential stress is equivalent to F by A. So here the tangential strain is equivalent to del L by L. So here L is the original length of that body. So here del L is the change in length. Okay, so after the application of stress, so what changes will be done in that material? So that is the ratio of strain, right? So the tangential strain is nothing but del L by L. So here look at this diagram. So here theta angle stress is applied to that material. So here the term. So initially it has in the order, so look at this cube. So here initially the cube has the values A, B, C, D. Okay, so now angle theta twist is applied to that body. So what will happen? So BC, so normally it has BC. So now it turned into BC1. So due to the application of theta stress, tangential stress, the strain will be produced from, initially it has a surface BC. So after application of stress, it has the surface will be changed and displaced from with respect to its fixed surface. Here the fixed surface is BC, the displaced surface is BC1, right? Okay, so the tangential stress strain is equivalent to del L by L. So apply the stress value and strain value in eta equation. So rigidity modulus is equal to tangential stress by shearing strain, right? So here tangential stress value is equivalent to F by A. Shearing strain value is equivalent to del L by L, right? So eta is equivalent to F by A divided by del L by L. So here tan theta is equivalent to del L by L. So tangent strain can be written as like tan theta. So here produced angle will be very small, so that tan theta is simply written as theta. So here we have applied only small cheering style. Okay, so tan theta is simply written as theta. So theta is equivalent to del L by L. So look at this equation. So instead of del L by L, we can write simply theta. So substitute here in eta equation. Eta is equivalent to F by A into E theta. So del L by L simply written as theta. So this is the rigidity modulus of that material, right? So these are all the another factors, factor of safety. So this will be explained in later videos. Thank you all.